This next section is called resonance structures. If you're still doing Lewis drawing, please stay there. Once you've mastered that, move on into resonance. So what I'm going to do is I'm going to talk about the nitrate ion. It's a beautiful example of something that has a resonance structure. As you look at these three pictures, each picture is a true Lewis structure. But which is the correct Lewis structure? I'll let you read what's written there, but what I want to point out is anytime you see a double-headed arrow, that is what's going to indicate resonance is possible. So let's attack the nitrate ion. Nitrogen, S2P5, 5 valence electrons. Oxygen, S2P4, 4 valence electrons. A grand total of 24. I'll put my nitrogen in the center. I'll put 2 electrons in between each nitrogen and oxygen. So of the 24, I have used 6. I have 18 electrons that are left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That is my Lewis structure for nitrogen, but it is not the correct structure because N is deficient. It does not have 8 electrons. So what I'm going to do is I'm going to draw you 3 different acceptable Lewis structures. One of them I'll use the oxygen with the A, one I'll use the B, and one I'll use the C. So it'll take me a little bit of time to draw it out. But here we have the one where we're using the oxygen labeled A, where when we use that oxygen, we are giving nitrogen an octet. And we have to put brackets around it, -1. This was our one that was called A. Now let's do our one called B. Here we have we don't do anything here. What we're doing is we're putting 2 pairs of electrons in between the oxygen I've labeled B and just drawing the rest in. That one I'll label -1 because it's a nitrate atom. So that's when we use oxygen A. Here's where we use oxygen B. Now what we're going to do is we're going to use oxygen C. And the question is, which one of these is correct? Well, all of them are Lewis structures. All of them would give us the same formal charges. All 3 structures are acceptable, okay? That's just what it is. So we would put that little double-headed arrow in between each one of them because each one of them is an acceptable Lewis structure. But how will we show this? Well, when we went in the lab and did an experiment using some techniques, it said that all 3 of the bonds are equivalent. Well, how can we show that on paper? What we'll do is we'll put all our atoms in, and instead of drawing any sort of line, we will draw these little dotted lines. And that tells a chemist that these are resonance structures, okay? We have the oxygens on the outside because we really have a hard time showing those extra things. And I guess I can't put them all in because they all don't fit. So that's essentially how I would draw my resonance structure. And this is the one that is accepted. It has delocalized electrons, all right? All of the A, B, C have localized electrons. When I do my resonance, it has delocalized, and we'll talk about that in chapter 9. So that's one example of the nitrate ion. The other one I want to show you is dinitrogen tetraoxide, okay? I'm going to do a little bit more of a shorthand here. 2 times 5 for nitrogen, 1 times 6 for oxygen. It gives me a grand total of 16 electrons. Now, nitrogen comes first, so I'm going to make nitrogen the central atom. And there I've used up 4 electrons, so I have 12 electrons left. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of the electrons are gone. But my nitrogen in the center does not have an octet. And there are 3 distinct structures that I could write that satisfy the Lewis octet rule. Here's the first one, and I'm going to put a bracket around it because it's resonance. Here's the second one. They take a while to draw because you have to count everything. And here is the third one. There, now we have all of our different Lewis structures. And it looks like on the second one, I put an extra 2. I did not mean to. But each of these is a Lewis structure. Each of them satisfies the octet rule. How am I going to be able to decide which one to use? Well, here's where I'll have to use formal charge. This is a distinct structure. This is a distinct structure. This is the first one, but what it is, I hate to use the word flipped, but it is flipped. We have a triple bond and a single bond. Here we have a single bond and we have a triple bond. So how can I decide? Well, I didn't have enough room here, so essentially what I'm going to do is figure out the formal charge. Let me put the rest of the electrons in. Here I have some more. I have to put a couple more in here, 2, 4, 6, 8. Here I have to put 2, 4, and I just have to put 2 over there. Now each of the atoms has an octet. They're bonded, one with a triple, one with a single, one with 2 double bonds. So it's very easy to assign my number of valence electrons. Nitrogen has 5 and oxygen has 6. I'm just going to write them in here and then we can chat about it. -5, -4, -7. Then we have -6, -4, -6. So when I do my math, I come up with a 0, +1, -1. Here I have a -1, a +1, and a 0. So how this is normally indicated is people just write the formal charge above the atom, okay? So here we have the formal charges written above the atoms. Now, it says the better structure is going to have the negative charge on the more electronegative atom. If I look at even just the periodic table, or if I look at the table of electronegativities, I will see that O has a greater electronegativity than N. And that's going to tell me that this is going to be the accepted structure based on formal charge. We'll go through this a lot slower in a Zoom lecture, but I wanted to get all the information here in this video. The last slide said, why are you learning this? Well, here's what you're going to learn in Chapter 9. Here's the nitrate ion. We talked about its resonance structure. We're going to talk then about localized and delocalized bonds. So that's coming up in Chapter 9. Now, if you're planning to take organic chemistry, we will be teaching you in Chapter 9 about these two resonance structures, how we can write them in this manner, and then we'll talk about the localized and we'll talk about the delocalized bonds. So please, spend some time in this chapter, learn your Lewis's for an individual atom, learn how to draw a regular Lewis structure, then teach yourself resonance. Before we can move on to Chapter 9, there is a section called Exceptions to the Octet Rule. So tune in next for that.